I can talk, is we are going to continue with conversions. On Thursday of last week, we started performing some conversions. Today, we're going to continue that process. So here we have one that asks us to go from 1.8 quarts into cubic meters. Again, we identify the piece of information we were given, which is the 1.8 quarts. And we identify what we want it to be in. We want it to be in cubic centimeters. Both of these are units of volume, but you will notice that there is no similarity in the terminology. Because there is no similarity in the terminology, that means we're talking English to metric conversions. So we start looking into our volumes and determine, okay, what could we use? Well, let's see. When I look at the conversion table, and you will receive a conversion table, one of the things I see is 1.0567 quarts is equal to 1 liter. Now, the reason I chose that is because centimeters cubed, one of the things I know is 1 milliliter is equal to 1 centimeter cubed. So I have a way to go between the English system of quarts to the metric system of liters, which ultimately will let me get to 1 milliliter is 1 centimeter cubed. So again, you start by listing out conversion factors that you may need. You may have all the conversion factors, you may not. We'll find out. So when we begin our calculation, we begin with the 1.8 quarts. Our first conversion factor has to have quarts in it. So we're going to use the first one I found, which is that 1.0567 quarts is equal to 1 liter. With that equality, you will notice that the quarts was placed in the denominator so that the unit cancels out, leaving liters. I next need to worry about liters. Well, I didn't have a conversion factor for liters, so that I realize I'm missing one. The one that I'm missing is 1,000 milliliters is equal to a liter. So that is the second one I'm going to use. Of that conversion factor, I'm going to put the liter in the denominator and the 1,000 milliliters in the numerator. I place the liter in the denominator so that the unit cancels out, leaving milliliters in the numerator. You always keep in mind what it is you are trying to solve for. I need centimeters cubed, so I need to convert that milliliters into centimeters cubed with the fact that 1 milliliter is 1 centimeter cubed. I place the milliliter in the denominator so that it will cancel out. And now I have performed the conversion. Now I need to do the calculation. This is the first time we've had a more complex calculation, so I'm going to go over this. When you're looking at the railroad track system, the lines that are, the parallel line means division, and the lines that are vertical means multiplication. So you can do this a couple of different ways. We can take that 1.8 and multiply it by 1,000 in order to get 1,800 in the numerator. And that is in centimeters cubed. Divided by then 1.0567 in the denominator. And you get a number of 17,000 or 1,703.4 centimeters cubed. which we then have to pay attention to sig figs. Our starting quantity has 2 significant digits. The liter portion of the quart to liter conversion is infinite, but the quarts have 5 significant digits. Your metric prefix conversions are unlimited numbers of significant digits, as is the 1 centimeter cubed is 1 milliliter. Therefore, we have 2 significant digits divided by 5 significant digits, so our answer should have 2 significant digits. So we would record this as 1,700 centimeters cubed. Questions? Yes.
Why is the 1.0567 not infinite if it was one of the conversion methods?
Okay, so the question is, why is 1.0567 not infinite since it's a conversion factor? The answer is because it is a measurement. The question you have to ask yourself is this exact or did this come from a measurement problem? If it's exact, meaning it was counted, then it would have been infinite. But if it came from a measurement, then it was not infinite. Does that answer your question? And so 1.0567 was probably somebody going, okay, I want a liter. How many quarts make up that liter? And the quarts were the measurement. Other questions? Okay, let's look at another example. Convert 120 milliliters into microliters. You start out with what you were given. We were given 120 milliliters, and we have been asked to put that into microliters. You have terminology in common. Both of these have liters. That means you're going to be using your metric prefix conversion factors to do this conversion. If you look up the milliliters, there's 1,000 milliliters in a liter. And if you look up micro, 1 liter is equal to 10 to the minus, 1 microliter is equal to 10 to the minus 6 liters. Now, you may have learned a different way. I know some people learn to count zeros and go back and forth. But it's just, for me, it's easier just to use the conversion factors as they come. I don't care which way you do it, as long as you're getting it correct. So if you have another way, that's a possibility. Okay, so we've come up with possible conversion factors based off of the units. So now let's do this conversion. 120 milliliters. Our first conversion factor needs milliliters in it. There's 1,000 milliliters in 1 liter. The milliliters are placed in the denominator so that they will cancel out, leaving liters in the numerator. We then use the next conversion factor that has liters in it. 10 to the minus 6 liters is equal to 1 microliter. The liter was placed in the denominator so that the unit would cancel out, and we're left with microliters. And when you key this into the calculator, you get 120,000 microliters. Now for significant digits. Your starting quantity had two significant figures because of the fact that you had a implied decimal point. Therefore, that 0 is not significant. Metric prefix conversion factors have unlimited numbers of significant digits. So both of your conversion factors had an unlimited number of significant digits. Your measurement with the fewest had two significant digits, so your answer can only have two significant digits. You can record your answer this way. You can also record your answer as 1.2 times 10 to the 5th microliters. Either one would be correct. Questions? Let's look at another example. Okay. So the first 5 or 6 conversions I did in this particular series, 3 on Thursday, 2 today, we were able to simply find conversion factors. We would go to the metric prefix table and find the conversion factors we need. Or we were able to go to an English to metric conversion table and find conversion factors that we need. What we're about to do is we're about to talk about units that are raised to a power. What we do when we have units that are raised to a power is we devise a way to get from the starting point to the ending point, just as we've been doing, using what is given as well as what you already know or can look up, just like what we've been doing. The difference is, if we're talking about something besides 1 milliliter is 1 centimeter cubed, we're talking about any other cubic or squared units, you're going to have to derive the conversion factor. And the way you derive the conversion factor is you are going to raise all of the numbers and all of the units to the appropriate power. So if I am looking at centimeters cubed to inches cubed, then I have to worry about raising the centimeter cubed to the inches cubed. Let's see what I mean by that. 2.54 centimeters is equal to 1 inch. These are not cubed. I can't just throw cube in there. Instead, what I've got to do is I have to cube the entire thing, meaning I have to take the 2.54 and cube it, the centimeters and cube it, the 1 and cube it, and the inches and cube it. 2.54 centimeters cubed is 16.387 centimeters cubed. And that is 1 cubed is 1, so 1 inch cubed. So 16.3887 centimeters cubed is 1 inch cubed. Technically, because I am cubing it and I'm talking about 3 sig figs, the 8 and the 7 would be dropped off, but I don't drop it off until the very end of a calculation. Let's look at this and use it. Calculate the displacement of 5.70 liters automobile engine in cubic inches. So I want to take the 5.70 liter automobile engine and I want to make that into cubic inches. Liters and inches have nothing in common. Therefore, I'm going to be using the English to metric conversions. When I look up English to metric conversions, one of the things that I will find is that 1 liter is equal to 10 to the third centimeters cubed. I chose this particular conversion factor because I needed to change, I needed to get it into something that I can use that would be considered a ruler type of measurement. And centimeters and inches, both are ruler type measurements. But I need to convert that that centimeter cubed into inches cubed. So I gave you one just a moment ago where 2.54 centimeters is equal to 1 inch cubed, and is equal to 1 inch, and we cubed that to come up with 16.387 centimeters cubed is 1 inch cubed. Now that I have possible conversion factors, I am ready to perform this conversion of 5.70 liters into inches cubed. My first conversion factor is going to have the liters in it. So 1 liter is equal to 10 to the third centimeters cubed. The liter went in the denominator so that it would cancel out, leaving centimeters cubed. The next one I'm going to use is the 16.387 centimeters cubed is equal to 1 inch cubed. The centimeters cubed goes in the denominator so that they will cancel out, leaving inches cubed. When you key this into the calculator, you get 347.8 inches cubed. Now, we have to figure out sig figs. Our starting quantity had 3 significant digits. 1 liter to 10 to the third cubic centimeters. The liter is infinite, so is the 10 to the third. 1 inch is infinite, whereas the 16.387, if you'll recall, had 3. Therefore, our answer should only have 3. We're dropping something that is greater than 5, so we would record this as 348 inches cubed. Questions? Let me give you this one to work on. For those that need it, 1 yard is 3 feet. 1 foot is 12 inches. And 2.54 centimeters is in an inch. But you talk to me how to do that. This is about, well. As far as the English to metric conversion. This is about as hard as it's gonna get. With this, what I started with is I started with yard cubed and I needed to convert that into centimeters cubed. So I had 2.11 yard cubed. I knew that 1 yard is equal to 3 feet. So my first task was to cube that. And when I cubed that, I got 1 cubed, which is 1 yard cubed, is equal to 3 cubed, which is 27 feet cubed. I placed the yard cubed in the denominator so that it would cancel out, leaving feet cubed. But I need centimeters cubed, so I went the next step and I had 1 foot is 12 inches. And I cubed it. So you had 1 cubed, which is 1 foot cubed, is equal to 12 cubed, which is 1728 inches cubed. I placed the foot cubed in the denominator so that it would cancel out, leaving inches cubed. But I needed centimeters cubed. So then I did the same one that we did previously, where we took the 2.54 centimeters and equals 1 inch, and I cubed that so that I got 16.387 centimeters cubed is equal to 1 inch cubed. And I placed the inches in the denominator with the centimeters in the numerator, and then I multiplied. In this case, it was all divided by 1, so I just multiplied. And I got 1,061,000 as my answer. The number of significant digits, because 1 yard is 3 feet, that is a exact quantity. So is the cubed. Because 12 inches in a foot is an exact quantity, so is the cubed. And because 2.54 centimeters is equal to 1 inch is an exact quantity, so is the cubed. Or you could look at it as there were 3. Either one works. But anyhow, there are 3. One thing you may note, probably the simplest thing, 99% of the time, these conversion factors, they're going to have more significant digits than your original measurement. 99% of the time, you can base your significant digits off of whatever is in the question. 99% of the time. And so a lot of times that's what I do is I base it off of what's in the question and not all the conversion factors. But you could base it off of everything. It's just a lot of times what's in the question is going to be the determinant factor. Questions? Yes.
So I'm looking at the sheet on that you're like gonna give us the exam. Those are all the exact numbers that have infinite significance.
They either are that. Here's the problem with that conversion table. And the reason I base everything off of what's in the problem. It all depends on what conversion table I give you. I can go find multiple conversion tables and they're going to have them to multiple different digits. And so a lot of times I try to find one that has it, that yes, you can base it off of it. But no, not all of them are infinite. It's just, you have to think about, does this makes sense to be an exact number or not. Question? Let's look at another problem. We're going to get into, now what we're doing is I'm going to get into some problems where there's information in the problem itself so that there's multiple numbers in the problem. A vineyard has 145 acres of Chardonnay grapes. A particular soil supplement requires 5.50 grams for every square meter of vineyard. How many kilograms of soil supplement are required for the entire vineyard? Which is 1 kilometer squared is equal to 247 acres. Okay. I always start by making a list of the information I was given. I was given 145 acres. I was also given this 5.5 grams for every square meter. So that means it's 5.50 grams of supplement per 1 square meter. And I was also told 1 kilometer squared is equal to 247 acres. The reason I've given you this problem is because one of the questions is, where do you start? Again, 99% of the time, start with something that has only one unit. Don't start with the conversion factor. Though you, I mean, folks, you can do it, but it makes it more complicated. It's easiest to start with the thing that has only one unit. So I'm going to start with the 145 acres. My first conversion factor needs acres, and we have 247 acres is 1 kilometer squared. The acres went in the denominator because I needed to cancel. So far I used the starting quantity and I used the one conversion factor. I need to use the next conversion factor, but in order to use that, I have to convert kilometers squared into meters squared. So I think about this, and what I know is 1 kilometer would equal 1,000 meters. But you got to square that. So that's going to be 1 kilometer squared is equal to 1,000 squared, which is 1 million. Meters squared. The kilometer squared goes in the denominator with the meter squared in the numerator. And now I can use my other conversion factor to get it into grams of supplement. But you must always pay attention to what you wanted to sell for. I need kilograms of supplement. Well, I know that there is a 1,000 grams in 1 kilogram. So the grams go in the denominator so that the unit cancels. And now I'm ready to do the math. And what you get is 3,228.7 kilograms of supplement, which we would round to 3.23 times 10 to the third kilograms. And that's supposed to be a times 10 to the third kilograms. Questions? Yes, I'm doing a lot of conversion factors because I know that this is a challenge for individuals. And I want to give you as many examples as I can for when you're actually doing them yourself. So before we get going into I think I've got one more problem. Maybe two. I have a question, or I have a series of questions, and I want your feedback. What are things that you notice about conversions? What are some of the things you noticed that we have done today about conversions?
Most of the information is already given in the problem.
There's a lot of information is given in the problem. Specifically, folks, I'll give you anything that's not in the tables. If it's in the tables, I won't give it to you. But I would give you things that, especially where you have to go from different types of units. One of the things you'll notice is if you have different types of units, math compared to, the distance that was given to you. Area, I should say, that was given to you. That's always going to be given to you, is when you've got something so different. It's always going to be in the problem. What else did you notice as I perform conversions? Depending upon the conversion, you can square and cube them. But specifically, you got to square or cube everything. You can't just cube or square the unit. You got to cube and square everything within the conversion factor if you need to do so. What else?
Can be solved systematically.
Can be solved systematically. Can you expand on that?
Identify step by step and through without harmony magic.
It can be solved step by step. There's really no magic in it. How is it solved step by step? What's something that you notice when I'm doing this step by step by step? Conversion factors. Folks, if you use just numbers, the major thing I see is people want to shorten the process by getting rid of units. You can't do that. You may get lucky and put them all in the correct way, but for the most part, you don't do that. That's why it's called dimensional analysis. It's because you got to have the unit. And you'll notice I always went acre, acre, kilometer square, meter square, meter square. Every single step, I'm looking for, how do I get rid of that? That's what went into the next denominator. How do I get rid of that? That's what went into the next denominator. That is what I think of when I think of systematic. Now, density as a conversion factor. We've already done some density. Now we're going to do density as a conversion factor. And you can think of the density triangle. Density is mass divided by volume. Mass is density times volume. Volume is mass divided by the density. But you want to know what else you could do? You could follow your units. It's just another dimensional analysis. You can follow your units. But some people like the density triangle, so I give you both. Let's look at an example. No, I just did that. Ethylene glycol, which is antifreeze, has a density of 1.11 grams per centimeter cubed. What is the mass in grams of 226 milliliters of ethylene glycol? Step number 1, list out what you were given. We were given a density, 1.11 gram per 1 centimeter cubed. We were given 226 milliliters. Which of those units am I going to start my calculation with? Milliliters, because there's only one unit associated with it. Now, I know I got to use the density because density is your only conversion factor that is going to have mass and volume. Those are two different types of units. That's the conversion factor that's going to have mass and volume. But in order to be able to use that, I've got to get this milliliters into centimeters cubed. So I go into my memory bank and I know 1 milliliter is equal to 1 centimeter cubed. The milliliters I placed in the denominator so that they would cancel out, leaving me centimeters cubed. And now I can use that density of 1.11 grams per 1 centimeter cubed. I place the centimeter cubed in the denominator so that it'll cancel out, and I'm ready to do some math. And I get an answer of 251 grams. Questions? Let me give you this one to work. Acetone has a density of 0.7857 grams per centimeter cubed. What is the volume in liters of 4.2 kilograms of ethylene glycol? Look, that's supposed to be acetone. What is the volume of, in liters of 4.2 kilograms of acetone? This is supposed to be about acetone. Okay. I was given the density. I was given 4.2 kilograms. Because 4.2 kilograms has only one unit associated with it, that is where I started my calculation. Now, to be able to use this density, I had to convert the kilograms into grams. I did so with the fact that there's 1,000 grams in 1 kilogram. Now, density. I'm able to use it because I do have grams, but in order to use it, I've got to flip it upside down. So that the grams wind up in the denominator and the centimeter cubed in the numerator. That had to occur in order for the grams to cancel. Now, centimeter, I ultimately was asked for liters, and anytime I think of liters, I think of milliliters, which allows me to go to centimeters cubed. So that's why I use 1 centimeter cubed is equal to 1 milliliter, and so that the centimeters cubed would cancel out and leave me the metric conversion, or the metric system of liters. And then I converted that into the milliliters and the liters and got 5.3 liters. Questions? Before I do this problem, I want to remind everybody of SI tonight. What time is it tonight?
6 o'clock.
6 to 6:50. And what will you be covering tonight?
Everything from last lecture and starting this lecture.
So there will be conversions in it, and I say that with the fact that I know that it is one of the more challenging things that we've done so far. So, and that will be in room 105. So if you're needing additional help with conversions, please go to SI. Now let's look at this problem. The mass of fuel in a jet must be calculated before each flight to ensure that the jet is not too heavy to fly. A 747 is fueled with 172.231 liters of jet fuel. If the density of the fuel is 0.798 grams per centimeter cubed, what is the mass of the fuel in kilograms? Let me give you a moment to work on that one. And I actually have real world experience with this because I had one of my flights was diverted. They didn't have enough fuel that we wound up circling DC and we were getting low on fuel. So we had to be diverted to another location because they didn't have quite enough for that purpose. Should have gotten 137 kilograms. You take the 172.231 liter. Now I converted it to milliliters and then to centimeters cubed in order to use my density. Using the density allowed me to get it into grams, and then I converted it into kilograms, and that's how I got the 137 kilograms. Questions? Let's look at this one. A proton has a radius approximately 1 times 10 to the negative 13 centimeters and a mass of 1.7 times 10 to the negative 24 grams. Determine the density of a proton. Consider the proton as a sphere and therefore the volume can be calculated using the equation volume is 4/3 pi r cubed. So in this particular case, we have been told the radius of this sphere. We have been told the mass of the proton. We have been asked for the density. If we want the density, density is mass divided by volume. We have the mass, we need the volume. And they told you that this is a sphere, so the volume is 4/3 pi r cubed, where the r is 1.0 times 10 to the minus 13 centimeters. So 4 divided by 3 times pi times, and that's cubed. Meaning that the volume is equal to 4.189 times 10 to the minus 39 centimeters cubed. So now we can plug it into our density equation. So that would be 1.7 times 10 to the minus 24 grams divided by 4.189 times 10 to the minus 39 centimeters cubed. Ooh. And you get a density of 4.058 times 10 to the 14 grams per centimeter cubed. Now, this, I was like, and so we would record this as 2 sig figs, so 4.1 times 10 to the 14 gram per centimeter cubed. We're talking something on that size, yes, it would have this density, but we're talking something super small. And so you would, it's an extremely dense object. An atom is an extremely dense object. A proton is an extremely dense object. Questions? Here, I just needed to calculate the density. I just had to get it in the appropriate units to calculate the density. Okay. For Thursday. You need to watch the history behind an atom of an element. You need to watch the how to figure out the number of protons, neutrons, electrons in an atom of an element and its atomic number, mass number. I will not spend a lot of time on the background. I will get to the nuts and bolts of what's going on. So you need to come to class prepared. Because I will not take time for you to write down all of the background information that's in the in-class PowerPoint. I'm gonna go through that rather rapidly and we're gonna get to problems. And we're gonna work the problem. So keep that in mind. That is the plan for how this class is gonna run. And we are now a week into class. We can do it. I will see you on Thursday, except for 15 of you, which need to come see me by tomorrow at 2 o'clock. I don't know, is it everything but divisional analysis? And that's in the flip classroom.
The conversion sheet that you said we're gonna have to know some conversions.
You're gonna have to know the metric conversion.
That's the
1,000 mils is equal to a liter, or 1,000 mils, milliliter is equal to a liter, or the micro to molecular. Those different.
Okay.
So remember when I saw you, but I put out to the news? Do you want me to come back? Because I can't.
No, because you came to my office, so I remember seeing. So.
Thank you.
I was like struggling with some of the stuff that we did. Which flip lectures were covering this lecture?
This was dimensional analysis,
Okay,
and
so-
it did the bare minimum
Mhm.
in the discussion online. That's why I did so many problems today.
Okay,
There will be also the optional homework,
okay.
and then there will be,
I planned on going to the SI section,
okay.
but the only thing that I didn't understand, it's like I understood how you put everything into the the graph that you used, but I didn't understand the end calculations
Okay,
because that was a little bit confusing to me.
so there's multiple ways that you can do those calculations. Yeah, I've got a later too. Let me shut everything down and I'll. Gotta get to the right. End.